So what we're looking at today is writing equations of parallel lines and perpendicular lines. Okay, so what are parallel lines? How would you describe them? Never cross? Okay, perfect. So if they never cross, what are they going to have in common when you think of writing an equation? The same what? Same slope, yeah? Because if they have the same slope, they're never going to cross. Make sense? So if two non-vertical lines in the same plane have the same slope, they are parallel. If they're parallel, we can assume, vice versa, they have the same slope. Okay, so parallel is going to be easier than writing perpendicular. So first way we might look at it, or the way you might be asked, is write an equation of a line that passes through a given point here, so -3, -5, and is parallel to this line. Okay, well, since we know they have the same slope, all we need is the slope from this line, and that is in slope-intercept form. So what is the slope there? 3, yeah. We don't care about that y-intercept. We don't need it. Okay, well, now we have a slope, and we have a point. So we can write an equation now in point-slope form. So we'd have y plus 5 equals our slope, 3, and then x plus 3. And that's it. You're going to write it in whatever form is easiest. So since we're given a point and we have the slope, point-slope is going to be the easiest. Okay, so another one like that. We're given the point -2, -11, and we want it to be parallel to this line. So what would be the slope of that line? Yeah, -1. So now we have a slope and we have a point. So we'd have y plus 11 equals -1, and then parentheses x plus 2. Good so far there? Okay, then another way you might be asked is I'm going to give you 3 different equations, and you have to tell me if any of them are parallel. Could be none of them, could be 2 of them, could be all of them. You just got to find the slope. Okay, so the easiest one to find the slope from is A here. That's already in slope-intercept form. What's the slope of that line? 5. For the next 2, we have to solve them for y to pick out the slope. So what would be our first step to solve that for y? Yeah, subtract x, or if you want to write 1x minus 1x. You'd have 5y equals 2 minus 1x. And then your last step there would be to do what? Divide by 5. So there we can see our slope now. It's in front of x. So that slope is -1/5. Is that the same as 5? No. So we know those two aren't parallel. And then you just check the third one. So same steps. We'd add the x, so add 10x to move that over. And then divide by -2. So you get a slope of -5, because that's going to turn into y equals -5x. Help if you can see it. Okay, so this shows on these how important signs are. Because if you miss a sign here and put +5, you're going to say that C and A are parallel. But are they? No. 5 and -5 aren't the same. So we would just say none are parallel. And you're going to see that symbol right there abbreviated for parallel a lot. Just 2 lines drawn parallel. Okay, one more like that. On these 3, B is the easiest one to pick out the slope because it's in slope-intercept form. What is the slope of B? 3. Okay, so we know that one's 3. You go back to A, solve that for y, move your x over. And then divide by your 5. So we get a slope there, -2/5. Okay, so we know that's not the same as 3 again, right? So if we check the third one, same steps again. Move the x over, add 1.5x. 4.5y equals 6 plus 1.5x, and then last, divide by what? 4.5. And you don't even have to go to the trouble of simplifying this all the way out, because we don't even really care what the y-intercept is, right? We just need the slope. So 1.5 over 4.5 is going to reduce to be 1/3, which is not the same as 3, right? Or negative 2 over 5. So this would be another one that none are parallel. So you'd be looking for at least two that have the same slope to be parallel. All right, last, a word problem might come up in parallel lines. Says, while nursing, blue whale calves can gain weight at a rate of 200 pounds per day. Two particular calves weigh 6,000 pounds and 6,250 pounds at birth. Okay, so what they're giving us now, this number, what is that, our slope or the y-intercept? What is this? I was trying to say it right. What does per tell us? Slope, yeah. So we got a slope of 200. Anytime you see per or each, that's going to be your slope. And then this is worded a little different than we've seen before. They're giving us two starting weights. So don't get this confused with like a point for point slope. A starting value is a y-intercept. It's an initial value. So if we wanted to write two equations that represent those two, we have a y-intercept of 6,000 for this one and a y-intercept of 6,250 for that one. And we know the slope for both of them. So one equation would be 200x plus 6,000. And then our other one would be 200x plus 6,250. So part B now is asking us how much would each one weigh after 30 days. Well, X is representing days because it's 200 pounds per day. So we would just go plug in 30 for both of the X's here. So we got 200 times 30 plus 6,000. That gives you 12,000. So that one would weigh 12,000 pounds, and the other one would weigh 12,250. Okay, which leads us to C, which is making you just want you to pick out why they're not changing, or why the difference is always going to be the same. If these equations were graphed, how would they be related? If the slopes are the same, they are what? Parallel. So they'd be parallel. And if they continue to gain weight at the same rate, will they ever weigh the same? No. That would mean, would the lines ever cross? So no. The difference will always be what? What's the difference between the two starting weights? 250, yeah. So no, they will always weigh 250 pounds different. So anytime your slopes are the same, the difference between the two will always be the same. All right, we good up until that point. Turn the page. All right, perpendicular line is going to be slightly harder because instead of the slope being the same, it's different, but different in a certain way, the same way each time. So two lines in the same plane are perpendicular if they intersect to form a right angle. We all know what a right angle is, right? Okay. So horizontal and vertical lines would be perpendicular. Okay, so it says, what is the slope of the line with the y-intercept at 0? And it didn't show up on the copy. Can y'all see that? See how it looks like there's a line right here? If you look really closely. For some reason, that black line came out clear on the copy. All right, so the y-intercept is 0 for this line. So if we find another point, the next point would be here. So that slope would be up to right 3. So that slope would be 2/3. If we look at the other line, if we pick out 2 points to find that slope, there's a point there, there's a point there. Is that a positive or negative slope? Negative. And we're going down 3, right 2. So if I'm telling you these two lines are parallel, look at the two slopes and tell me how you could get one of the slopes from the other one. What would you have to do? What would I have to do to the fraction 2/3 to make it become -3/2? Just in layman's terms. You don't have to give me math terms how we get there. What do you do to 2/3 to get 3/2? Someone just flip it, right? You flip 2/3, you got 3/2. And then we change the sign. That's what you have to do to find a perpendicular slope. What we call it is opposite reciprocals. The opposite because we change the signs. Reciprocal because we're flipping the fraction. So just to give you a couple other examples of that, if I told you one slope, was 4/5. The perpendicular slope, and you're going to see perpendicular abbreviated like this, an upside down T. The perpendicular slope to 4/5 would be -5/4. Flip it over, change the sign. Or if I gave you a slope of -3/4, the perpendicular slope, if we flip that over and change the sign, would become +4/3. So if one of them is negative, when you change it to get the perpendicular, it should become positive, or vice versa. They should never be the same, positive or negative, because there's no way you can have two lines that are both positive or both negative that are perpendicular to each other. So for this plane, this is where it's wrote up here. So if two lines in the same plane are perpendicular, their slopes are opposite reciprocals. Now the ones you have to be careful of and not get tricked up by are whole numbers. If you have a slope that is 2, and you want to write the perpendicular slope, first thing I would do is write this as 2/1. That way you can see when I flip it, it's going to become what? 1/2. Yeah, so that perpendicular slope would become -1/2. So anytime you get a whole number, I'd put it over 1. At least until you get really used to doing this. That'll help you figure out what it's going to be when you flip it. Okay, so the type of examples we're going to look at, same type of problems, it's just now instead of parallel slopes, we want a perpendicular slope. So if we want to write an equation of a line that goes through that point, 4, -5, and now is perpendicular to this line, first thing we need is the slope of this line, which is what? 2. So I'm going to write that as 2/1. So if we want to make the perpendicular slope to that, it would become what? -1/2. So now we have the slope we need, and we have a point. We go back and write it in point slope form. So y + 5 equals -1/2, and then parentheses x - 4. Okay, same thing on the next one. So if we want an equation of a line that goes to the point 4,3 and is perpendicular to this line, y = 4x - 7. Okay, so what is the slope of that line? 4. So that's 4/1. So the perpendicular slope would be what? -1/4. Most forgotten part typically is the sign. Usually everyone remembers to flip it. Sometimes people forget to change the sign. So there's our slope. There's our point. So we'd have y minus 3 equals negative 1 over 4. And then parentheses x minus 4. Good with those two? Okay, example 2 down here, once again, comparing them. Now, these can be a little trickier because with parallel lines, we're just looking for two that are the same. Now we have to find two that are opposite reciprocals of each other. So you got to be careful about how you pick them out. So, and that is, should say A there, that's a typo. So on letter A, what is that slope? 5. Okay, don't flip them or change them yet, just write down what that slope is. Then we'll compare them. So for B now, we need to solve for y. That's our first step. Yeah, so minus 1x. So I get you 5y equals 2 minus 1x. And then I divide by 5. And there we can see what our slope is now. That'd be negative 1/5. So before we even get to C, would these be opposite reciprocals of each other? Yeah, because that's 5 over 1, and that's negative 1 over 5. So for sure we know these two are perpendicular, correct? All right, now let me give you a little something when you're dealing with 3 lines. You don't have to write this down, I just want to show you on a separate sheet of paper. If I know those 2 lines are perpendicular, we've already decided that, right? For the third one to be perpendicular, it has to have the same slope as one of these. It either has to be going like that and be perpendicular here, or has to be going like that and be perpendicular there. So in order for you to have 3 where they're all involved somehow, 2 of them have to be the same. Does that make sense? Okay, because there's only 2 slopes that can be perpendicular to each other. So when we're looking at C, if it's not one of these 2, we know it's not perpendicular. So move your 10x over. So we're going to add 10x. So you get negative 2y equals 10x, and then divide by negative 2. So that gives us y equals negative 5x. So that slope is negative 5. Okay, so that is not the same as either one of these, so it can't be perpendicular to either one. Okay, once again, it shows you how important signs are. If you miss that sign, you're going to think it's like this one, and then all these would be perpendicular. So the only ones that are would be A and B. So we just say A and B are perpendicular. And I'm abbreviated with that upside down T again. Saves you writing out the word. Okay, one more like that. On the next one, once again, that should say A. So B is the one that's the easy one to pick the slope out. What's the slope there? 3. We go back here and solve for y. First, we're going to subtract 2x. So we get 5y equals negative 3 minus 2x. And then divide by 5. So we have a slope there of negative 2/5. Okay, so obviously that's not the opposite reciprocal to 3, right? So we know these two are not parallel to each other. Or sorry, perpendicular. Now we check C, same steps again. Add the x over, so plus 1.5x. So you get 4.5y equals 6 plus 1.5x. And then divide by 4.5. And if you reduce this, if you put this in your calculator, that's a slope of 1 over 3. Okay, so is there an opposite reciprocal to 1 over 3 there?
Yes.
There's a reciprocal, right? But is it opposite signs?
No.
No. Easy way to remember it is you're never going to have two positives that are perpendicular or two negatives that are perpendicular. So this one would be none are perpendicular. Once again, goes back to signs. If you miss a sign, you're going to think they are perpendicular. So you got to be very careful with signs. All right, so turn the page. And we're going to look at a word problem with perpendicular. So this one says a hockey puck leaves the blade of a hockey stick, bounces off the wall, and travels in a new direction as shown. So write an equation that models the path of the puck from the blade of the hockey stick to the wall. So for this equation. So we need a slope, and we're given a y-intercept here. You can't read that. That says 0, 8. So we know our y-intercept is at 8. So I'm going to put b equals 8. So for this line, is that a positive or negative slope? Positive. And the only thing to be careful of here is what this is counting by. This is counting by 2's in each direction. So our slope here, if you want to go all the way to this point, even though there's one right there, that's going up 2, 4, 6, 8, and then right 2, 4. So 8 over 4 gives you what? 2. So that's a slope of 2. So we can say that equation is y equals 2x plus 8. And then part B, we'll write the equation for the second part of the line, from the wall where it bounces off and goes this way. So is this a positive or negative slope for this one? Negative, right? And this one's going down 2, 4, 6, 8, right, 2, 4. So negative 8 over 4, which gives you what? Negative 2. So we got a slope of negative 2. So that line would be y equals negative 2x plus 8. Okay, so does that form a right angle? Are they perpendicular to each other? Got a slope of 2 and negative 2. Are they opposites? They are, but are they reciprocals? No. So, no, they do not form a right angle. For them to form a right angle, if that's 2, this would have to be negative what? Negative, flip this and change the sign. If that's 2 over 1, this would need to be negative 1 over 2, right? Or if we wanted to have this one, if that was negative 2, this would have to be positive 1 over 2. Otherwise, they are not. All right, we good there? All right, so what I'm going to do is where it says classwork, the rest of this, that's going to be your homework for those of you that already finished the quiz yesterday. So y'all can work on that. Those that still need to finish the quiz, I'm going to give you that back. And then once everyone gets done with that, then we'll go over the quiz.